Let's move on now to examining the nonparametric equivalent of the independent samples t-test. So if we wanted to do all this without ANOVA assumptions and use the underlying ranks in our data, we would use something called the Mann-Whitney U test. We find that in the Coin library. And despite its name, it starts with Wilcox because there are multiple authors of this test, and some people call it the Wilcoxon-Mann-Whitney test. So here we're going to run the test time by IDE, and we can see a significant p-value here, and we get a z-score as the statistic as a result. Now for drill, notice if I do the same test on log time, I get the exact same result. Well, why is that? Why would time as a dependent variable give me the same result as log time? Well, because taking the log transform of the data doesn't fundamentally change the rank order of the response. The rank order of all the measures would still be the same when the log is taken. So for a rank-based test, the result would be the same. Let's go now to our table of analyses and see where this has all brought us. So we've just completed another row in our analysis table. We saw for a single factor, in this case it was IDE, the programming environments, in 2 levels. We had Visual Studio and Eclipse. It was a between subjects factor because students only did one or the other of Visual Studio or Eclipse. The parametric test, the analysis of variance test, was the independent samples t-test, and the nonparametric equivalent, which did not need the ANOVA assumptions to be met, was the Mann-Whitney U test. Now let's continue our progression through this table as we look at adding a third programming environment to our experiment. That is, a third level to the IDE factor. And that will take us into a one-way ANOVA.